Hello everyone, welcome. Today we are going to understand why do I call something that SPYQ is very important for our preparation. This is the mains question of 2009. So the question says that obtain the relativistic equation for aberration of light, because that is directly written in our syllabus using velocity transformation equations. So solution is, suppose a light source which is an S prime frame. Okay, maybe it is an atom or something like that, which emits light. So it is moving along x-axis at a speed v, and then it emits light at angle theta prime with the x prime axis. So that is the pretty much you should know it. Okay, let me tell you. uh, this is x prime s prime frame, and this is the angle of light ray. Okay, and this is the s frame, this is s prime frame. Okay, and obviously we know this is going to be x prime axis, this is going to be y prime axis, and this is x axis, this is y axis. So this is our whole setup, and provided that you know what is Lorentz transformation, because velocity transformation equations are result of Lorentz transformation. So velocity of light in x prime direction is pretty simple. Okay, that is c multiplied by the cos component. Okay, cosine of c, and it is sine of c. Okay, we know that in this direction it is c times cos theta prime, and in this direction it is c times sine theta prime. So now we will directly put the available information in velocity addition formula. So from if you see the no, the speed of light from s prime frame, then you will notice ux as ux prime plus b divided by 1 plus b multiplied by ux prime divided by c square. This is exact formula. Okay, and when you solve this, you get ux. In simple manner, you get ui. The calculation is pretty simple, and you know ki there is sine theta and cos theta, and if you divide that, that is you divide uy divided by ux, you get tan theta, because c and c is going to cancel out. So tan theta is simply uy divided by ux. You put all the values, you get tan theta is equal to sine theta prime under root 1 minus beta square. Beta square is it is c upon v, the ratio of the sorry, v upon c. So this is the ratio. Okay, and divided by cos theta prime plus b. So this is the relativistic aberration of light. Okay, if theta prime is the angle of the light ray in s prime frame, then in s frame you get simply by this relation. Now let me tell you, they can ask the same question in this format. Obtain the relativistic equation for aberration of light using the Lorentz transformation equation. There is nothing much difference, but there is something you need to adapt to. So again, you will do the same thing, whatever the uh, diagram we had there, we will have here. Consider a train of plane monochromatic light wave with amplitude emitted from a source. Amplitude is unit, okay. Source of origin S prime, reference frame. And here we have definition of aberration. I have written it for your additional information. So rays, or you say wave normals, are considered parallel to x prime y prime plane. Okay, that is they are in x prime y prime plane. So you will have to write the equation which describes the propagation. So as the amplitude is unity, so here we have 1. That is why you cannot see it. And this is the most basic equation of any wave. And it is k prime dot producted with r. Okay, k is obviously the propagation vector, and everything is in the s prime frame. That is why all the quantities are in s prime. So, and we just written that we expanded that, we multiplied k with r prime. We multiplied the components, we took out the 2 pi, and here is all the mathematical detail. It is pretty easy, class 12 level mathematics right now. You are just doing dot product, so don't think that it is something very hard. If you break it, you will do it easily. And Amplitude is I think this is wrong. It is not infinity, it is unity. Okay, we have written it earlier. Amplitude is unity and it moves with the velocity c, which is uh, frequency multiplied by wavelength in theta prime direction as specified in the figure. And we know that it is a frequency and lambda prime is wavelength of the wave. Now we need to transform the above in the S-plane because that is what Lorentz transformation says us to do. So this is the transformed equation. Okay, something which is without the primed quantities. Okay, we call this as a prime quantity. Okay, so here unprimed quantities are measured in S prime. We have the general convention S prime and sorry, S frame and S prime frame. That is the difference. We try to keep it everywhere so that we don't confuse ourselves. And here again, speed of light is this. Okay, and it is one very basic thing, the second postulate of Einstein's special relativity, that is speed of light in free space is same in all reference frames. So that is why it is here also c, it is here also c. Now we apply the Lorentz transformation to equation 1. So what you will get, you know that Lorentz transformation says that x prime is Lorentz factor multiplied by x minus vt if the movement is along x axis. Y prime will have no change, Z prime will have no change, and time will have slight change. Okay, so this is the basic thing. So we just put all the, this is the value of x prime, this is y, just y prime. Okay, and this is the value of time. Okay, from this value to this value, and gamma is nothing but the Lorentz factor or relativistic factor. We know it is mathematically equal to 1 divided by 1 minus v square upon c square whole under root. Okay, I have written it here as well. And beta is nothing upon nothing but v by c. So when you do all the necessary equation, then when you compare, because now you have transformed, okay, so on comparison the components should be same. So on comparison we got that cos theta divided by lambda is equal to cos theta prime plus beta divided by this. And again you have got two equations, one involving cos theta divided by lambda, one is sin theta divided by lambda. So when you divide that, you will simply get the aberration of light. But we have two more information here as well. This is about frequency and this is about light. Okay, so we got all these on comparison, we did compare them. Simple. So know that this whole question is much theoretical. They can ask question from here, they can ask you aberration of light, and they can ask about the frequency as well, how frequency is taking effect, and from here you can get the Doppler effect. Okay, so this is what I call SPYQ, that is questions which are similar to PYQ. And I think this is very innovative idea to keep in mind while you study things. Okay, so let us meet in the next part of our journey, not in this question.